Let's proceed with the next problem. Okay, here we're supposed to find what is Vx. Vx is a drop across this 20 ohm resistor. So we need to find what is the voltage across this 20 ohm resistor. And one more thing we can look into this is that this is a 1 mark problem. That means it's not going to be that complicated at all. It's going to be simple. Maybe the circuit looks a little complicated with two dependent sources and the way it's connected, but it's fine. Let's see how we can proceed. Okay, I'm going to apply KCL again for this problem. So I'm going to consider this one node and this one another node. Okay, so for this node, if I write KCL, the current incoming current will, one of the incoming current is 5 amperes, that's going upwards. The other currents can be going this way. So one is 5 ampere, the other one's flowing this way and this way, right? One up going through this. All right. So if I see the current, this current is divided here, right? Whatever the current flowing through this 10 ohm resistor and this 20 ohm resistor, the sum of these two currents is the equivalent current here. So at this node, if I write the equation, I can say 5 amperes current is equal to the current that is leaving, that is 0.5 Vx, 0.5 Vx plus the other currents, these two currents, some of these currents to 10 ohm and the current to 20 ohm. Why? Because this is the equivalent current we have to think about. So this current is equally, not equally divided, but the whole current will be divided among 10 and 20 in 1:2 ratio. That's fine. That's not important right now. This whole current is divided among these two branches. That's what is important. So I'll consider these two branches. So what will be the potential at this point? That's important for us to know. So because I'm supposed to write the current equation for this 20 ohm resistor. So the drop across these two ends of the 20 ohm resistor are important for me. This point is 0. This is ground. So I can say it's a ground point. So that's not a problem for me. 0. So but this point is important. And we are given that Vx is a drop across 20 ohm resistor. That means what? This one end subtracted, this one end potential minus this one another end potential is equal to Vx. It is this point minus this point equal to Vx. This point is already at 0 volts. So no problem. So this Vx will be totally seen at this point. So I can say this node is Vx. The potential of this node is Vx. Okay, alright. So the potential of this node is Vx. So I can write the current through this the path, downwards branch is will be equal to Vx by 20. And the current going through 10 ohm will be Vx minus this potential. I do not know what is this potential, so I'll call it V2. So Vx minus V2. It's Vx minus V2 divided by 10 ohms. Okay, so this is the equation we got. Now let us look into this V2. This V2, what is V2? That is important. This is one variable that we need to know. Or let us write a KCL over here. That also we can do. And then find the relationship between Vx and V2. But when you look into this circuit, one thing is very clear. The 0.25 Vx, this voltage source is directly connected to ground, isn't it? This is all is ground. This is all will be ground. So till these points, it's all going to be 0 volts because the drop occurs only after an element. So the current flows to an element, the drop occurs. So these are all the same voltage points. So 0 volts. So as this is connected directly to 0 volts, I can say the effective voltage here will be 0.25 Vx. So this V2 will be equal to Vx. So I can substitute V2 as Vx here. So this V2 will be changed as 0.25. Oh, sorry. Here V2 is not equal to Vx. V2 is equal to 0.25 Vx. Correct? This is not just Vx. 0.25 Vx is the effective voltage seen. Alright. So this is equal to, the second change it as, again I'll raise it and write. So this can be changed as 0.25 Vx. Okay, so let's proceed. The next equation. So this, if I take the, okay, let's first substitute and then write. I'm taking 20 as LCM. So 5 into 20 equal to 0.25 Vx into 20 plus Vx, then plus 2 Vx minus, we have 2 into 0.25, that will be 0.5. So 0.5 Vx. So this is 100 equal to this was 0.5. This is 0.5 into 20. That makes us a 10 Vx. 10 plus 3 minus 0.5 Vx, the whole Vx. So now Vx, this all comes together as 13 minus 0.5, that is 12.5. So Vx will be equal to 100 divided by 12.5. And that gives us 8 volts. So the answer for this question is 8 volts. Okay, thanks for watching. Let's continue the next problem.